Alright, so this is going to be part 2 of my internal Pop the Hood series of videos covering some of the systems of the Shadows platformer. And right now, I'm just going to take a detailed tour of the player's finite state machine and animation controller and how it's put together, a few of the decisions that were made in putting it together and why those decisions were made, and the logic behind them. So as I said, in that order, we're going to start with the player character controller, which is fairly simple right now. We start off in the idle state, as has already been seen, and we can transition to the run state based on the absolute horizontal throw, and provided the character controller isn't in a state that it shouldn't be in when grounded. I do this based on horizontal control throw because the character originally tended to slide a little bit, and it still to an extent does, and I'm tuning that to get it just right. But when it slided, I didn't want the character continue showing the running animation uh, when you were no longer pressing the key down. And I found that the slide was also a lot less noticeable if the character went into idle when it went to do the slide. And I can show that off right here. Starts off in idle. You get to moving, and the character goes to the goes to the running state. As soon as you let go of the key, transitions back. Over here, I have separated the airborne and climbing animation states into their own sub-state machines because they've got their own sort of thing going. In airborne, we have a jump and fall state. It enters the jump when it gets the trigger that says it's now switched to the airborne state, and it will stay in jump until the vertical velocity gets to a point where the character is now moving downwards, and in which case it will go into the fall. And it can break out of this state given the right conditions. In the climbing state, we have a very similar idea here. It's got a idle state, which is currently the same as the character's regular idle, for when you're in the climbing character finite state, but not actually moving, because I don't want to be showing the running animation, which is currently what I use for climbing. If you're not doing anything, it just kind of looks weird. Then I've got climbing, the actual climb animation over here, which is separate from the run animation, even though it uses the same graphics, because I don't have a climbing animation, because it in the animation itself, both for the run and the climb, it has special audio cues at the points where I say that looks like when the character's foot hits the ground, or when the character's hand would have hit the wall if there was a climbing animation. And that's when I play the sounds so that they're kept as in sync as possible, and it doesn't sound weird if you've just got a looping audio effect. These do not go by vertical velocity, they go by absolute vertical control throw, for the same reason that I use absolute horizontal control throw for running. I think it looks better if you only ever see the animation play when you're actually trying to move in that direction. And of course this is using absolute because I don't care if you're moving up or down, I just care that you're moving at all. And it's got a die animation that it can get to from any state, which has already been seen. When you fall out of the world, the character sort of goes into his panic state. There's different logic for all of these conditions that try to check that states that the exit conditions are right for the state. That wasn't very explanatory, but I don't want to waste too much time on the animation controller. It works basically as you expect it would. There's not too much going on there. The next thing I want to look at is sort of work my way up from the states. Originally, I designed these states with the idea that they would be their own compact module and they had all of their logic implemented in it. But I started seeing a lot of code duplication where I ran a method in each of the states that was basically the same for every state with minor modifications depending on certain conditions. And I took a detailed look at Unity's 2D game kit to sort of see what they were doing and why they were doing it, to see what information could be gauged. And one of the things I really liked was how they set up their finite state machine states. And I noticed they had sort of this list of what you were capable of doing in the state, and it had no implementation detail. It didn't really care how you did these things. It just said, these are the things I can do in this state. And I thought that was so much more expressive and compact, and it removed code duplication. So I immediately went through and refactored all of these states to be more like a list of what you were capable of doing in that state. Oh no. As opposed to having all of the implementation detail right in that state. And again, since these are actually classes and not mono behaviors that implement an interface for a movement state, I inject the dependency in each of these for the player controller and its locomotion components and the settings so that it can access those values at runtime. Actually, I've already shown that one. I wanted to move to locomotion. This used to be the same. It used to be merged with the player controller script, but one thing I think Unity did poorly, and this is just my personal opinion, I believe, is that their player controller script got ungodly bloated with methods, and it was kind of a nightmare looking at it. And so one thing I've taken extra care is to split my player controller along the domain lines as much as possible so that each class is only doing one thing and follow that adherence to the solid responsibility principle, or the single responsibility principle. So all of the moves were expedited to this class, as well as the state variables that sort of track whether you're capable of doing those moves again. And we've got quite a few in here for glide, air jump, wall jump, and jump. And these two make calls into the actual jump function. And there's these are basically your list of everything the character can do and what it means when it actually does that. Now that this is set up into a separate script, if I ever wanted to replace this, put it through an interface and just say, okay, these are the moves the character has to be able to do, I don't care how you implement them, that's something that I want to do later down, something that I know I'm capable of doing since it's been split off now, following the solid principles, so that if I ever have a level that I want to have different moveset, or I need to completely redo how the moveset works and I want to do that in a separate class, I have that option open to me now. And also, if I want to change a move, instead of having to go to player controller and find it in there, it's now in its own class, which is a bit easier to work with. Going up into the player controller, here we have the actual serialized fields for the player settings and the checkpoints. We have a region off here for all the states and the current state that we're in. A reference to the input and locomotion, and I don't think I use that anymore. I'll have to look at that. That might be a bug, some potential refactoring to go on there. I have some events. I'm meaning to update my entire delegate system to use scriptable object-based events to be a little bit more expandable and designer friendly, to where you can change the logic of the game with even less code, but I haven't gotten to that yet. It's on the bucket list. Going down to start, we sort of set up everything that we need. I find the foreground tile map for the surface checking. Right now it has to be tagged as foreground. That's one of the constraints I've set. It's possible to make it serializable, but I wanted to find it programmatically so that when I make a new level, so long as this design constraint of tagging the foreground as a foreground, then I won't have to constantly grab the foreground out of the scene and place it into the player script every time I make a new level. I can just click, drag the player in, it's good to go. It has everything, every link that it needs to function properly. Anyway, going down into fixed update, over here we're updating the animation floats for those control throws and the velocity, and it runs the update for the current state that it's in, which will always be this method here that says move horizontal, check flip, that kind of thing. Going down from there, it checks if you've fallen out of the world. Currently this is sort of a new system that is obviously, as you can see, very, very placeholder, because I wanted to get falling out of the world working, and I don't have a health system yet, so it was just rough and fast and loose, implement it and refactor it later as soon as I actually have a working health and potentially life system in there. It has the respawn method, which is actually a coroutine, so that I can add a little bit of delay there as I want. Updates the animation state and teleports it back to the last checkpoint, which I might have glossed over is there's a checkpoint system. I don't know where I've stored that anymore. Oh, here we go, right here. You can always serialize the first checkpoint, which would be the place that you start from. And there's a very simple checkpoint code that says when you enter a trigger collider, it will set the checkpoint on the player controller to the one that is corresponding to that trigger collider's checkpoint. I have checks here for if you're gripping and gripping a wall or touching the ground. A check here for if you have a surface, or what the surface beneath you is, assuming you have one, and a check here for if you're climbing, what the surface is that you're facing. Very simple teleport wrapper method that just changes the position. I did this in here as opposed to changing it in the position wherever I wanted to teleport the player, so that if I want to execute custom logic, maybe play a sound or raise an event that executes custom logic, I don't have to go through and change all of the places where I teleport the player to use a method call because I just updated the transform directly. No, it's right here, and if I ever need to make a modification to how teleporting works, I only have to make it in one place. So I've saved myself some future headaches there, even though it's basically a wrapper for one line of code. It's pretty important to me to have it, not changing that value from anywhere where it shouldn't be directly modified. A simple snap to wall feature, method, not feature. Feature, yes, anyway. Forget that. Why this exists is in the past when you would run up to a wall, it was very unpredictable. There was very little constraints. I never absolutely knew how far away from the wall you would actually be. There were times where you could get stuck on the wall or where you would disconnect from the wall. It was just this constant battle of trying to get wall climbing to work the way I wanted it to, and it never quite turned out the way I wanted. So I've got it to where it now puts on an X, or a constraint for the X movement, so that you can't break off the wall unintentionally. If you're intentionally trying to break off the wall, you won't have any problem. And I've added this snapped wall that raycasts to the wall and then places you the correct distance away from it, which is also a customizable setting in player settings, so that I always know that it's going to be somewhere that works. You're never going to get stuck on a wall, and it removes some of the uncertainty and ensures that the state never enters something that it shouldn't be in, where a bug would be made possible. I have physics wrappers here for setting the constraints to what I need them to be. Very simple stuff, and again, I have simple wrapper methods for even single lines of code, because I know that I don't want these to be changed elsewhere directly in case that I need to change how this little bit of code functions and add new lines, saving myself the headache again, sort of protecting myself for the future. And a simple method for flipping the character and setting the checkpoint. Some of these are a little bit more public than I'd like them to be, but at the moment there's a bit of tight coupling between all the player classes because I don't have as many interfaces as I should, but I'm aware of the problem, and going forward, if it's going to be an issue, then I'm going to write up the interfaces while it's still easy and simple to do, so that I have that safety net for the future in case suddenly I need to make massive changes and it's like, oh, I don't have interfaces, oh no, this is going to be bad. It'll be possible to make those changes without sort of having to rip out huge blocks of code, and be able to slate in entirely new classes with different behaviors that will just work. But again, right now, this is a very simple sort of player controller, so it's not a big issue for me. These transitions, which I've just opened up here, these ones I'm bothered by. I don't like how it's currently done. They cross domain lines a little bit too freely for me, or my taste. But at present, the states themselves have their own exit methods, and they do that to wrap up their own sort of internal state to make sure that everything's neatly tied up. But over here, I want to have a centralized point where I'm setting these animator values, so that in the future, once I get to it, I can split off all the graphics code from the actual logic, and having this here just means I have fewer places elsewhere to look for it. like I said, I'm not 100% happy with how these transitions are done and how manual it is to add a new state and then add the transitions for it, and how this list could grow exponentially bigger. And I have plans for how I could reduce it and ensure that I'm safe from it being just this massive transition list method, or list of transition methods in the future. But again, it's just the game is only a few days old, so a lot of systems are like, I'm going to do that as soon as I have time. So moving on from there, we have the player audio over here. And again, this is pretty tight coupling with the actual player controller and locomotion, because it needs to be able to subscribe to their events. And so ripping the player audio out would probably, or ripping out the dependency from player audio would probably be the hardest out of all of them to do because of the event system. But that's why I'm trying to get a scriptable object event system implemented, so that this will be very, very loose coupling, and I won't have to worry about, oh, if I change how the player locomotion works, then I need to be able to make sure the events can be subscribed to. It'll be a different kind of system that'll be more expandable and designer friendly. And over here, as you can see, thanks to the implementation of the surface material system, this method that used to be very long, had a disgusting switch statement. I hate switch statements, by the way. And I did not like it. I did not like how manual it would be to extend it. So I made the new surface system, and now I believe it's very, very clear what this method is doing. It's nice and short, and it expedites the behavior that it doesn't need to know about to the surface manager system. And I like that. This method has been drastically reduced by that. And overall, yeah, I think it's just a massive improvement. And the last class that I wanted to particularly look at is over here, the input. This one, conversely, would be the easiest to have an interface for, that I can create pretty simply, so that I can replace this input. But right now, as you can see, it's extremely bare bones, very, very simple with how it executes its logic. And so I'm not terribly concerned. I could rip this whole thing out, and with how few lines of code it is and how easy it was to make, I wouldn't really care that much. It's so small that I'm not that worried about it, but I know in the future that I want to make this better and support my own input wrapper for rebindable keys, but that's coming down the pipeline. So I know in the future I'm almost certainly going to replace the entirety of this or change a huge bulk of how it works. So I'm not too keen about making it perfect now, because I'm going to do that later and completely replace it. It's coming down the pipeline. And that, I believe, is it for the player character controller. We can take one more look at all of it working in action, transitioning between the different states. If you are on the wall without moving, again, no animation plays until you actually start moving. Start that glide. And that's about it. That is how the player animation controller works. If you want to take a deeper look at all of the code, the entire source code for this project is available on my GitHub. I should note, by the way, just a side note, all of this is made with free assets off the asset store. Barring the wood sound effects. Those I got off free sound. They're CCO though, so it's fine. And that's it. Oh crap. That's it for now. Everything that I needed to show. And so this is going to be the end of this video.